Assalamualaikum and greetings to Sir Mio and the other viewers. My name is Muhammad Ilman bin Muhammad Idlan, matrix number AS11114, and this video is our presentation on the chapter 42.1, which is early developmental stages. So in my part, I'll be explaining about the organ stages of development.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Saya Zulaika binti Zakaria, AS10763 dari Kuliah 8. Hari ini, saya ingin membentangkan mengenai fertilization.
My name is Nur Ain binti Budi and my matric number is AS10867. I will present about cellular stage of development.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Aikila Uzma binti Nur Hisam, the matrix number AS10823. I will present to you about tissue stage of development.
Kita mulakan dengan the definition of fertilization, which is the union of the sperm and egg to form a zygote. Kat mana fertilization ni berlaku? Dekat tiuk fallopian. Dan kita akan tahu apa itu sperm. Kita kena tahu sperm punya parts and apa yang ada dekat parts tu serta apa function dia. So dekat head, nampak tak yang warna biru pekat ni yang mengelilingi ni, dekat bahagian head ni adalah membrane bound, which is acrosome. And then yang warna merah ni adalah haploid nucleus, which contains 23 chromosome. Okay, apa function acrosome ni? Acrosome ni dia ada digestive enzymes that allow the sperm to penetrate the egg. Nanti kita akan tahu macam mana dia berfungsi sewaktu proses nanti. Seterusnya, middle piece. Middle piece ni dia ada banyak mitokondria untuk produce banyak ATP. Kenapa dia kena ada banyak ATP? Sebab dia memerlukan banyak energy. Sebab dia, sperm ni kena swim. Alright, the last part is tail. Tail ni dia ada flagellum. Flagellum ni is a whip-like structure that allow the sperm to swim. And then, female egg, which is secondary oocyte. Bila saya cakap female egg je, saya maksudkan secondary oocyte. Sebab sperm ni dia akan berjumpa dengan secondary oocyte. Alright, kalau korang nak tahu perbezaan secondary oocyte dengan primary oocyte, dengan follicle semua tu, korang boleh je search dekat Google. Tapi, bagi nak meringkaskan, secondary oocyte ni, dia sebenarnya belum selesaikan dia punya meiosis 2. Maksudnya belum complete meiosis 2 lah. Alright, dia akan complete meiosis 2 bila sperm dah masuk. Alright. So, kita bincangkan berdasarkan dia punya layer. The first layer is corona radiata, which terdiri daripada adhering follicular cells. Function dia adalah untuk memberi nutrien kepada oocyte semasa dia adalah follicle of the ovary. Okay. The second layer is zona pellucida. Nampak tak yang warna kuning cair ni? Dia adalah extracellular matrix. Okay, function dia adalah tempat di mana sperm akan bind before dia masuk kepada the third layer, which is plasma membrane. Alright. So, the third layer, plasma membrane, function dia adalah untuk fast block. Nanti dalam proses kita akan terangkan macam mana fast block tu. Okay, kita masuk kepada fertilization process. Actually, bagi saya, untuk senang, saya bahagikan kepada 3 bahagian. The first part of fertilization process is sperm competition. So, it begins with million of sperms. Tapi hanya few hundred saja yang reach the egg. Yang reach the egg ni, dia akan cover the surface of oocyte. Okay. And dia akan secrete enzyme yang akan melemahkan corona radiata. Corona radiata tu kan yang first layer tu kan. Kenapa? Sebab dia kena squeeze through corona radiata. Barulah dia boleh bind to zona pellucida, which is the second layer. Dekat zona pellucida tu dia ada specific binding sites yang kita panggil genome. Okay. So, daripada zona pellucida tu, macam mana dia nak pergi kepada plasma membrane? Time ni acrosome dia akan release digestive enzymes that akan buka laluan forge pathway through zona pellucida to the oocyte plasma membrane. The second part is the events to prevent polyspermy. Okay, polyspermy ni maksudnya maksudnya banyak sperm kan. Tapi secondary oocyte ni dia nak satu je sperm. So dia kena prevent polyspermy ni. Macam mana dia nak prevent? So akan berlakulah fast block. Fast block ni, oocyte plasma membrane, dia akan depolarize, dia akan change its charge to repel sperm for a few seconds. Sebab itulah dipanggil fast block, sebab for a few seconds sahaja. And then slow block, oocyte vesicle, which is cortical granules, dia akan secrete enzymes untuk mengubah zona pellucida tu. Kan zona pellucida tu kan jadi ialah tempat di mana sperm akan bind kan. Tapi dia akan ubah zona pellucida tu into an impenetrable fertilization membrane. Maksudnya tak boleh dah bind. Macam tu lah. So dia dipanggil slow block sebab it is a longer lasting cortical reaction. Maksudnya lama lah. Bukannya fast. Slow block. And then the last one is Juno molecules. Juno molecules ni dia akan dibebaskan, release from the oocyte to prevent further specific interaction. Macam yang kita tahu, Juno tu adalah nama lain bagi specific binding sites dekat zona pellucida tu kan. So bila Juno molecules ni dia di-release kan, dah tak ada dah lah specific bind tu, specific interaction. Third part is formation of diploid zygote. Okay, bila satu sperm dah masuk, oocytes microvilli ni dia akan bring in the sperm, bawa the sperm masuk. And then sperm punya nucleus dia akan release its chromatin. Alright. Lepas tu secondary oocyte ni pun macam yang saya cakap tadi, dia belum complete lagi meiosis dia. Tapi bila sperm dah masuk, dia akan complete dia punya meiosis. Meiosis tu lah untuk lebih spesifik. Alright. Lepas tu single nuclear envelope akan surround the egg and sperm pronucleus. Diorang ni akan ada microtubules yang dekatkan diorang, and akan ada only one nuclear envelope yang akan surround the egg and sperm pronuclei. So 23 campur 23 dapatlah 46. So sekarang ni dia dah jadi diploid. So first cell division occur. Jadi video ni mengenai
Fertilization
proses
is the epic story of a single sperm facing incredible odds to unite with an egg and form a new human life. It is the story of all of us. During sexual intercourse, about 300 million sperm enter the vagina. Soon afterward, millions of them will either flow out of the vagina or die in its acidic environment. However, many survive because of the protective elements provided in the fluid surrounding them. Next, the sperm must pass through the cervix, an opening into the uterus. Usually, it remains tightly closed, but here the cervix is open for a few days while the woman ovulates. The sperm swim through the cervical mucus, which is thinned to a more watery consistency for easier passage. Once inside the cervix, the sperm continues swimming toward the uterus, though millions will die trying to make it through the mucus. Some sperm remain behind, caught in the folds of the cervix, but they may later continue the journey as a backup to the first group. Inside the uterus, muscular uterine contractions assist the sperm on their journey toward the egg. However, resident cells from the woman's immune system, mistaking the sperm for foreign invaders, destroy thousands more. Next, half the sperm head for the empty fallopian tube, while the other half swim toward the tube containing the unfertilized egg. Now, only a few thousand remain. Inside the fallopian tube, tiny cilia push the egg toward the uterus. To continue, the sperm must surge against this motion to reach the egg. Some sperm get trapped in the cilia and die. During this part of the journey, chemicals in the reproductive tract cause the membranes covering the heads of the sperm to change. As a result, the sperm become hyperactive, swimming harder and faster toward their destination. At long last, the sperm reach the egg. Only a few dozen of the original 300 million sperm remain. The egg is covered with a layer of cells called the corona radiata. The sperm must push through this layer to reach the outer layer of the egg, the zona pellucida. When sperm reach the zona pellucida, they attach to specialized sperm receptors on the surface, which triggers their acrosomes to release digestive enzymes, enabling the sperm to burrow into the layer. Inside the zona pellucida is a narrow, fluid-filled space just outside the egg cell membrane. The first sperm to make contact will fertilize the egg. After a perilous journey and against incredible odds, a single sperm attaches to the egg cell membrane. Within a few minutes, their outer membranes fuse and the egg pulls the sperm inside. This event causes changes in the egg membrane that prevent other sperm from attaching to it. Next, the egg releases chemicals that push other sperm away from the egg and create an impenetrable fertilization membrane. As the reaction spreads outward, the zona pellucida hardens, trapping any sperm unlucky enough to be caught inside. Outside the egg, sperm are no longer able to attach to the zona pellucida. Meanwhile, inside the egg, the tightly packed male genetic material spreads out. A new membrane forms around the genetic material, creating the male pronucleus. Inside, the genetic material reforms into 23 chromosomes. The female genetic material, awakened by the fusion of the sperm with the egg, finishes dividing, resulting in the female pronucleus, which also contains 23 chromosomes. As the male and female pronuclei form, spiderweb-like threads, called microtubules, pull them toward each other. The two sets of chromosomes join together, completing the process of fertilization. At this moment, a unique genetic code arises, instantly determining gender, hair color, eye color, and hundreds of other characteristics. This new single cell, the zygote, is the beginning of a new human being. And now the cilia in the fallopian tube gently sweep the zygote toward the uterus, where he or she will implant in the rich uterine lining, growing and maturing for the next 9 months until ready for birth.
Ini lebih kurang summary proses fertilization tu. Korang boleh tengok juga dekat buku media. I think that's all from me. Minta maaf salah silap. Terima kasih.
Next is embryonic development, and it can be divided into 3 major stages. First is cellular stage, second is tissue stage, and third is organ stage. I will present to you about cellular stage of development. During the early stage of development, an organism is called an embryo, and the cellular stage have 2 parts. First is cleavage, and second is formation of the blastula. Cleavage is a cell division without growth. DNA replication, mitotic cell division occur repeatedly, and the cell gets smaller with each division. So we can know at this picture, the early stage of development are exemplified in the lancet. So following the fertilization, the zygote undergoes the cleavage. Cleavage is a cell division, so zygote will divide, and cleavage in lancelet result in uniform cell that form a morula. After that, the morula will continue to divide and forming a blastula with a hollow and full-split blastocore. We can see in the picture the shape of the blastocore in the blastula. As you know,
The blastocoel form when the cell of the morula extrude Na+ into extracellular space and water, followed by osmosis and collecting in the center. After the cleavage occurs, the gastrulation will occur in the tissue stage and it will present by achila. Next is before that, all vertebrata have a blastula stage, but the appearance of the blastula differ between animals. We can see like chicken and frog. So in the first picture, the blastula is resemble a layer of cell that spread out over the yolk. This is because the yolk contains a dense nutrient material and yolk fillet cells do not participate in cleavage. So that's why the chick blastula spread out over the yolk. After that, the blastocoel then forms as a space that separates this cell from the yolk. So we can see in the first picture, the blastocoel make a space between the chick blastula and yolk. The next example in frog. In frog, cleavage is not equal because of the presence of the yolk. When yolk is present, the zygote and embryo has hybrid polarity, and the embryo forming has an animal pole and a vegetal pole. We can see in the second picture, animal pole is a blue and the vegetal pole is a yellow. So animal pole is for smaller cells that develop into ectoderm and endoderm layer and contain faster growing. For the vegetal pole, for larger cells that develop into endoderm and contain slower growing. So that's all from me. Thank you.
I'm going to present to you about tissue stage of development. Tissue stage of development involve gastrulation, the formation of a gastrula from the blastula. The two tissue stages are the early and late gastrula. The early gastrula stage begins when certain cells begin to push or invaginate into the blastocell, creating a double layer of cells. Cells migrate during this and other stages of development, sometimes traveling quite a distance before reaching a destination, where they continue developing. As cells migrate, they feel their way by changing their pattern of adhering to extracellular protein. An early gastrula has two layers of cells. The outer layer of cells is called the ectoderm, and the inner layer is called the endoderm. The endoderm borders the gut, but at this point, it is termed either the archenteron or the primitive gut. The pore or hole created by invagination, which is inward folding, is the blastopore. And in the lancelet, the blastopore eventually becomes the anus. Gastrulation is not complete until three layers of cells will develop into adult organs are produced. In addition to ectoderm and endoderm, the late gastrula has a middle layer of cells called the mesoderm. These pictures illustrate the comparative development of mesoderm between the lancelet, frog, and chick. First, in the lancelet, mesoderm formation begins as outpocketings from the primitive gut. These outpocketings grow in size until they meet and fuse, forming two layers of mesoderm. The space between them is the coelom. The coelom is a body cavity lined by the mesoderm that contains internal organ. In humans, the coelom becomes the thoracic and abdominal cavities of the body. Next, in the frog, cells containing yolk do not participate in gastrulation, and therefore they do not invaginate. Instead, a slit-like blastopore is formed when the animal pole cells begin to invaginate from above, forming the endoderm. As you can see in the picture, the peach color is the endoderm. Animal pole cells also move down over the yolk to invaginate from below. Some yolk cells, which remain temporarily in the region of the blastopore, are called the yolk plug, which is the yellow color one. Mesoderm forms when cells migrate between the ectoderm and endoderm. Later, the mesoderm splits, creating the coelom. Lastly, in a chick-leg gastrula, a chicken egg contains so much yolk that endoderm formation does not occur by invagination. Instead, an upper layer of cells becomes ectoderm, and a lower layer becomes endoderm. Mesoderm arises by invagination of cells along the edges of longitudinal furrow in the midline of the embryo. I repeat, mesoderm arises by invagination of cells along the edges of longitudinal furrow in the midline of the embryo. As you can see, mesoderm is between ectoderm and endoderm, which is the pink color one. Because of its appearance, this furrow is called the primitive streak. Later, the newly formed mesoderm splits to produce coelomic cavity. That's all from me. Thank you.
For my part, I'm going to be explaining about the organ stages of development. As Akila has explained just now, in gastrulation, three embryonic germ layers are formed, which are the ectoderm, the outer layer, mesoderm, the middle layer, and endoderm, the inner layer. So these layers will later on evolve and develop into organs. So what ectoderm, it will develop into the nervous system, the tooth enamel, the oral cavity, and the rectum. The mesoderm, the middle layer, it will develop into the musculoskeletal system, the cardiovascular system, gonads, and kidney. The gonads are the primary reproductive organs of female and male. And the endoderm, the inner layer, it will develop into the epithelial lining of the digestive and respiratory tract, the thyroid and parathyroid glands. So firstly, we're going to focus on the main point, which is the development of the nervous system. So in the development of the nervous system, it will develop from the midline ectoderm located just above the notochord. So what the notochord is a newly formed mesoderm cells that are merged and located along main longitudinal axis of the animal. It is replaced by vertebral column in later development, but only remains in lancelets. So as you can see here, what I said just now, it develops from the midline ectoderm, which is here, located just above the notochord, this black dot right here. And the notochord is a newly formed mesoderm cells. As you can see, these are a line of mesoderm cells. So this part, notochord, will be replaced by the vertebral column in later development, except for lancelets. So then at first, then a thickening of cells called neural plate is seen along the dorsal surface of the embryo. And then the neural folds will develop on either side of neural groove and forms the neural tube when it folds and fuses with each end. And at that point, the embryo is then called neurula. As you can see right here, the thickening of cells that I just mentioned is called the neural plate, which is this whole area right here, and along the dorsal surface of the embryo, which is here. And the neural fold will develop on either side of neural groove. So on this fold, as you can see, it folds inside and forms the neural tube. It folds and fuses together. So as you can see here, neural tube formation, it will develop into a neural tube just like this one. And at this point, the embryo is called a neurula. So then an anterior end of the neural tube will develop into the brain, the central nervous system, and the rest will become the spinal cord. And the neural crest cells, which are located here at the notochord right here, when it forms a notochord, there will be neural crest cells, the ones that are detached from the ectoderm. They will migrate to various locations and help form skin, muscles, adrenal medulla, and ganglia of PNS. And the mesoderms that are not involved form two longitudinal masses that later become somites, while the endoderm forms a primitive gut tube. And as you can see here, these somites are actually the end result of the expanding of the mesoderm. it will form two longitudinal masses that have these cavities which are called coelms. So what this cavity does is it actually forms into the main body cavities such as the thoracic cavity and the abdominal cavity. And besides that, the primitive gut here, as you can see, is actually the result of the expanding of the endoderm, which causes a space here which is called the gut. So what these somites do, actually, they are populations of cells that give rise to important structures, which is such as dermis, the skeletal muscle, the cartilage, bones, and tendons. So as you can see, this is the end product, and the ectoderm forms the outer layer of the embryo. These cells, as I said, will form the bones, the dermis of the skin, and also the tendons. And the endoderm lining here will help to form the respiratory tract and also the digestive tract. So what the notochord is actually important for is in the early process of neurulation, it will help in forming the neural plate over here. So if there is no notochord, the start of the neural plate will not occur and there is no neural tube to be formed. You can see here, this is an example of development of the neural tube and coelom in a frog embryo. As you can see, the ectodermal cells that lie above the future notochord here, called the presumptive notochord, will taken to form a neural plate. A neural plate just like this one right here, the one that involves a neural fold and a neural groove. And then the neural plate will fold inside and form this mass of cells from the ectoderm and will continue to expand upwards and form a neural tube. And the mesoderm here will split and produce two longitudinal masses, which I explained just now, with coelom, completely lined with mesoderm. And the gut here will form a bit of space and form the primitive gut. And the end result is a neurula with a neural tube and a coelom, and coelom in the mesoderms. So that is all from me. Thank you.